Hi guys, today we're going to study about cross product and we're going to solve some of its examples. So first, what is cross product? In mathematics, the cross product or vector product or occasionally directed area product to emphasize the geometric significance is a binary operation on two vectors in three-dimensional space or R cube and is denoted by the symbol x. Given two linearly independent vectors A and B, the cross product A cross B is a vector that is perpendicular to both A and B and thus normal to the plane containing them. The cross product A cross B is defined as a vector C that is perpendicular or orthogonal to both A and B, with a direction given by the right-hand rule and a magnitude equal to the area of the parallelogram that the vector spans. The standard basis vectors I, j, and k satisfy the following equalities in a right-hand coordinate system, where I cross j is equal to k and j cross k is equal to I and k cross I is equal to j, which imply by the anti-commutativity of the cross product that j cross I is equal to negative k and k cross j is equal to negative I and I cross k is equal to negative j. The anti-commutativity of the cross product also implies that I cross I is equal to j cross j is equal to k cross k is equal to 0 or the zero vector. These equalities, together with the distributivity and linearity of the cross product, are sufficient to determine the cross product of any two vectors A and B. Each vector can be defined as the sum of three orthogonal components parallel to the standard basis vectors, where A is equal to A sub 1i plus A sub 2j plus A sub 3k and B is equal to B sub 1i plus B sub 2j plus B sub 3k. Their cross product A cross B can be expanded using distributivity, where A cross B is equal to A sub 1i plus A sub 2j plus A sub 3k cross B sub 1i plus B sub 2j plus B sub 3k is equal to A sub 1 B sub 1 times I cross I plus A sub 1 B sub 2 times I cross j plus A sub 1 B sub 3 times I sub k plus A sub 2 B sub 1 times j cross I plus A sub 2 B sub 2 times j cross j plus A sub 2 B sub 3 times j cross k plus A sub 3 B sub 1 times k cross I plus A sub 3 B sub 2 times k cross j plus A sub 3 B sub 3 times k cross k. These can be interpreted as the decomposition of A cross B into the sum of 9 simpler cross product involving vectors aligned with I, j, or k. Each of these 9 products operates on two vectors that are easy to handle as they are parallel or orthogonal to each other. From this decomposition, by using the mentioned equalities and collecting similar terms, we obtain A cross B is equal to A sub 1 B sub 1 times 0 plus A sub 1 B sub 2 times k minus A sub 1 B sub 3 times j minus A sub 2 B sub 1 times k plus A sub 2 B sub 2 times 0 plus A sub 2 B sub 3 times I plus A sub 3 B sub 1 times j minus A sub 3 B sub 2 times I plus A sub 3 B sub 3 times 0, which is equal to A sub 2 B sub 3 minus A sub 3 B sub 2 times I plus A sub 3 B sub 1 minus A sub 1 B sub 3 times j plus A sub 1 B sub 2 minus A sub 2 B sub 1 times k. Meaning that the three scalar components of the resulting vectors S is equal to S sub 1 I plus S sub 2 j plus S sub 3 k is equal to A cross B, where S sub 1 is equal to A sub 2 B sub 3 minus a sub 3 b sub 2, and s sub 2 is equal to a sub 3 b sub 1 minus a sub 1 b sub 3. And s sub 3 is equal to a sub 1 b sub 2 minus a sub 2 b sub 1. Using column vectors, we can represent the same results as follows. In matrix notation, the cross product can also be expressed as the formal determinant as you can see below. This determinant can be computed using Sarrus rule or cofactor expansion. Using Sarrus rule, it expands as written below, where A cross B is equal to A sub 2 B sub 3 minus A sub 3 B sub 2 times I, minus A sub 1 B sub 3 minus A sub 3 B sub 1 times J plus A sub 1 B sub 2 minus A sub 2 B sub 1 times K, which gives the components of the resulting vector directly. So for our first example, find the cross product or vector C if vector A is equal to 2i plus 2j plus 5k and vector B is equal to negative I plus j plus 2k. We know that vector C is equal to vector A cross vector B. So first, let's construct a matrix. So we're gonna arrange the I, j, and k on the top row and the components of vector A on the second row and the components of vector B on the third row. And now, let's find the components of I. Let's cross multiply the second row of j to the third row of k minus to the product of second row of k to the third row of j. And that gives us I times to the product of 2 times 2 minus to the product of 5 times 1, which is equal to negative 1i or negative I. And now, let's find for the components of j. Get the product of the second row of I and the third row of k minus to the product of second row of k and the third row of I. And that gives us negative j times to the product of 2 times 2 minus to the product of 5 times negative 1, which is equal to negative 9j. And for the components of k, get the product of the second row of I and the third row of j minus to the product of second row of j to the third row of I. And that gives us plus k times to the product of 2 times 1 minus to the product of 2 times negative 1, which is equal to positive 4k. So, the cross product of vector A cross vector B is equal to negative I minus 9j plus 4k. For our next problem, if vector A is equal to negative 2, 2, and negative 3, and vector B is equal to 1, 0, and 3, find the cross product of a vector A and vector B. So again, vector C is equal to vector A cross vector B. So to find vector C, we must write it on a matrix method so that it's easy for us to understand and solve the problem. Let's arrange the I, j, and k on the first row and the components of vector A on the second row, and on the third row is the components of vector B. So let us now solve for the components of I. Cross multiply the second row of j to the third row of k minus to the product of second row of k and third row of j. And that gives us I times to the product of 2 times 3 minus to the product of negative 3 times 0, which is equal to positive 6i. To find the components of j, cross multiply the second row of I to the third row of k minus to the cross product of the second row of k to the third row of I. That gives us negative j times to the product of negative 2 times 3 minus negative 3 times 1, which is equal to positive 3j. And for the components of k, cross multiply the second row of I to the third row of j minus to the cross product of the second row of j to the third row of I. And that gives us plus k times to the product of negative 2 times 0 minus 2 times 1, which is equal to negative 2k. After we get the components of I, j, and k, now let's put it into an equation, and that gives us vector c, or vector A cross vector B, is equal to 6i plus 3j minus 2k. That's the end of our lessons today. I hope you learned something in this video. Thank you for watching.